Okay, so exam 2. The final exam in this class, because there is no actual final. Okay, so let's think about what we covered since the previous exam, okay? So we started out talking about, so we had just talked about the discrete Fourier transform just before exam 1, right? And we talked about how the DFT was related, and its relationship to the DTFT. Okay, so that was kind of the way we started off in the beginning. Then we talked about FFT algorithms. Right, we talked about kind of these radix 2 algorithms, which meant that the length of the DFT had to be a power of 2. And we talked about these kind of like Cooley-Tukey and Good-Thomas algorithms where we could take any length and factor it into 2 numbers and get shorter DFTs, right? Then we talked about the sampling theorem, and that was a topic that we talked kind of, a couple lectures about the general sampling theorem and also things like, downsampling and upsampling and polyphase or multi-rate signal processing. Then we talked about filter design. And filter design, we talked about basically FIR, both in terms of least squares and Chebyshev. And we talked about IIR filter design, or you talked about it while I was gone, hopefully. And then we started talking about adaptive filters. And things like that included AR processes, Yule-Walker equations. We just talked about the Wiener filter and the stuff we talked about today, right? So that's kind of the big picture of what happened since exam 1, okay? So what I decided to do on exam 2 is basically, one problem, which is going to be 20 points, which is going to be true, false, and fill in the blank. So the reason I'm doing this is because there are lots of topics and lots of concepts that are very difficult for me to ask you a work it out on paper problem. I can't ask you to do a Cooley-Tukey FFT on the exam, right? And so this is a place where you need to study up on names of things and concepts, right? So what algorithm is used to solve problem X, right? So in general, wherever there seems to be an algorithm that I have given a name to, or some term that I said specifically that you haven't heard before, those are the kinds of things that would be good to keep in mind to know what algorithm matches up with what text, right? So in the fill in the blanks, there are lots of problems like that. And then the true-false ones are generally meant to do a quick test of, do you understand a basic concept, right? So I think there's maybe like 8 or 9 true-false and 10 or 11 fill in the blank, right? Or adding up to 20, right? 1 point each. No work is required, so unlike the rest of the exam, you can put whatever you want. I'm not going to give you any partial credit on those, so either it's right or it's wrong, because it's 1 point each. There's no shades of gray there. The second problem is on sampling, right? So you saw on the practice exam a similar kind of sampling problem about, you should typically expect to see something where I give you some continuous time signal, I ask you to sample it at some certain rate, or downsample it or upsample it, and tell me what happens, draw pictures of what happens in the frequency domain, figure out what happens if I were to, apply a filter to it and reconstruct it, that kind of thing. The third problem is on filter design. So again, the homework that you did on filter design, the long homework, should be a good guide to understanding how to design a filter, right? So, think about what you went through to design that. You designed the vector of amplitude responses, you figured out what the phase had to be for a linear phase filter, and then you went through different design methods for designing a filter. And so, again, this is a case where I may ask you to set up but not solve a system of equations, for example. you can look and see the kind of filter design problem that I asked on the previous exam, right, to give you some sense of the kinds of stuff that I can ask you to set up, right? And then the last problem is on basically, AR processes. So kind of similar to the stuff that you're working on in the current homework, right? So if you did the past few homeworks and you understood them, then this exam should follow kind of along with those homeworks, right? So I think this is 30 points, this is 30 points, this is 20 points. So that's the way it's currently looking, and I don't think it's going to change too much between now and when you see it on Monday. Same as before, you can get 2 one-sided crib sheets, the one you used before and a new one, or if you want to have 1 two-sided crib sheet, that's fine. No calculators, I don't think you'll need them. And I'll give you all the tables that you had last time, although again, I don't think you're going to really need those either, because the stuff that we're doing now is a little bit more like algorithmic and process-oriented than solving kind of abstract Fourier and Z-transform problems. But I'll give you all the tables that you had before just so you have them. Okay, so questions or comments about the exams? Let's start with the format. Any ambiguity about that? Yeah? Will the filter design question be an IIR filter? So I guess short answer is no. I mean, like, you should know something about the lecture that I wasn't here to give, but at the same time, I don't think it's fair game to give you a detailed exam problem on something that you actually never did in the homework. But you should know the IIR filter design stuff for the first part of the problem, the first problem where you may be asked about things that relate to the stuff about IIR filters. Yeah?
Are you going to be strict on spelling?
Am I going to be strict on spelling? If I can tell what you mean, I think it will be fine, right? So I mean, this is what the crib sheet is for, right? You can write down what I wrote and it'll be fine, right? But you're not going to get dinged for things that I can understand what you mean. Other questions? All right, so how about other generic questions about, I don't know, whatever. Yes?
On the back exam, there was the first problem was like a TTMT, like the radius, that type of
Right.
factors. Is that going to be like leads or is that going to be more like just true false?
Right, so you'll notice the way I set this up that I don't have on this list a 20-point FFT problem, right? So any of the FFT stuff is going to be buried in the first problem. I think that's fair to say. But you should still know what that process is like, right? You should still know the names of things, stuff like that. No more questions? I'm giving you a lot more information about this exam than I gave you about exam 1, so hopefully it won't be a big surprise. Let's see. So just like before, make sure to show up, a few minutes before 10 o'clock so you can get a seat, get your stuff, arranged the way you like it, because I will start right at 10. I will have my office hours, as usual, this afternoon for questions or comments. Be sure to work the second exam as if it was a real exam. Give yourself the hour and 20 minutes and sit down and try and do it. I think that's good practice. It will also help you write your crib sheet, understanding the stuff you need to remember. Look back at the homeworks. The homeworks are a great preparation for understanding what I'm going to want you to do on the exam. All right. I could have lectured more about other stuff. 20 whole extra minutes. Question?
Will the true false questions have questions about
Will there be questions about MATLAB commands? I would say not as such. I mean, like, there are definitely some questions along the lines of, so long as you're short, Short answer. Yeah. Long story short, not really. But I mean, especially like the filter design problem will kind of be informed by your understanding about what you did in MATLAB to design that filter, for example. But no, it's not going to be like a CS1 exam where you have to write MATLAB code to do something like that. Okay, so then in that case, I will, before you guys go, I have your homeworks, so I think we can call it quits, and I will be around for questions, and you guys can come to my office hours if you like.